Welcome back to Algebra 2. Today we're going to do a review of right triangle trigonometry. So hopefully you picked this up in geometry, so this should be a quick review. If not, that's okay. This is a fairly simple topic that leads to more and more complicated things. But basically the idea is if I have a right triangle like this, if I have some angle, we're going to call that theta. Theta is like a 0 with a little line through the middle. Theta is a variable that just generally means we're talking about an angle. Now, the three sides of the triangle are noted in their relationship to theta. First of all, if I take the 90-degree angle and go straight across, that will always be the longest side of the triangle, so we call that the hypotenuse. If I go straight across from theta, that will give me something that we will refer to as the opposite side. And then the third side is the side that's touching theta, but it's not the hypotenuse, and we call that the adjacent side. Now, there are 6 ratios that are made using these 3 sides. So the first one is called sine. So we would say the sine of theta is equal to the opposite divided by the hypotenuse, where the cosine of theta would be considered the adjacent divided by the hypotenuse. The tangent of theta is equal to the opposite divided by the adjacent. Now, in order to get the other 3, we're just going to flip these over. So, the cosecant of theta is the hypotenuse divided by the opposite. The secant of theta is equal to the hypotenuse divided by the adjacent. And the cotangent of theta is equal to the adjacent divided by the opposite. Now, if I were you, I would make a handy little cheat sheet of this. We're going to use this enough that eventually you'll have it memorized, but at first it's really good to have a little reference sheet for this. So, first example, let's find all 6 of the trigonometric ratios for this triangle. So the first thing is, I know 5 and 12, but I don't know what the hypotenuse is. And hopefully the first thing that you think of is that's a right triangle. I can find the hypotenuse using the Pythagorean theorem. So the Pythagorean theorem, a squared plus b squared is equal to c squared, where a and b are legs of the triangle and c is the hypotenuse. So we would say 5 squared plus 12 squared is equal to c squared. So that would be 25 plus 144 is equal to c squared. So 169 equals c squared. Taking the square root of both sides, I would get c is equal to 13. Now that I have that, I can just label all 3 sides. So here's theta. Going across from the 90, there's the hypotenuse. Going across from theta, that is the opposite. And then the side that's touching, that's not the hypotenuse, is the adjacent. So, sine of theta is opposite over hypotenuse, so 12 over 5. Cosine of theta is the adjacent over the hypotenuse, so 5. Oops, I messed this up. 12 over 13. This one would be 5 over 13. The tangent would be the opposite over the adjacent, so that would be 12 over 5. And then the other three, I just flipped these over, so that would be the cosecant of theta is 13/12. The secant of theta is 13/5, and the cotangent of theta is 5/12. Now this second example is very similar to that first one, but it's phrased in a different way. So in a right triangle, theta is an acute angle and sine theta is 4/7. So evaluate the other 5 trigonometric functions of theta. So the important thing is sine theta is 4 over 7, and we know that 4 is the opposite and 7 is the hypotenuse. So if I go ahead and just draw a right triangle, here's 90 degrees, here's theta, I know that the opposite is 4 and the hypotenuse is 7, so that means I need to figure out what the adjacent is. So now I can just use the Pythagorean theorem again. 7 squared plus 4 squared plus b squared is equal to c squared, which is 7. So 16 plus b squared equals 49. We'll subtract 16 on both sides and we'll get b squared is equal to 33. If I take the square root of both sides, I just get b is equal to the square root of 33. So I can fill that in now. And I know that this is the opposite, this is the hypotenuse, and this is the adjacent. And now I can go ahead and fill in the rest. So the cosine of theta is the adjacent over the hypotenuse, so square root of 33 over 7. The tangent of theta is equal to opposite over adjacent, so 4 over square root of 33. Now this one does require that I rationalize the denominator, so it does take one more step of work, and that's just because I can't have a radical in the denominator for my final answer. So I just need to multiply this one by square root of 33 over square root of 33. Because in the denominator, square root of 33 times square root of 33 is 33. In the numerator, 4 times square root of 33 is 4 times square root of 33. So now we'll just invert these to get their counterparts. So the cosecant of theta is equal to 7/4. The secant of theta is equal to 7 over square root of 33. And again, I have to fix this by rationalizing it. So I would get 7 square root of 33 over 33. And then for the cotangent, I'm just going to flip this one over. Square root of 33 over 4. We're done. Now, solving a triangle with trigonometry, this is really kind of the main event. This is what we will be using this skill the most for. So if I know that one of the sides is a given value and I do know one of the angles, I can figure out the rest of the triangle. So first of all, the angles of a triangle always add up to 180 degrees. So if I know that angle C is 90 and angle A is 28, then angle B, if I add it, they're going to have to add up to 180. So I can just combine like terms and get 118 plus B equals 180. We'll subtract 118 from both sides and we'll get B is equal to 62. So now I've got that missing information. Now the sides are a little bit trickier. So what I'm going to do is take this angle right here, 28, and I'm going to look at the sides around it. So directly across from 28 is A, so that means A is the opposite. Directly across from the 90 degree angle, that's the hypotenuse, which means that B is the adjacent. So right now what I'm going to do is pick, I want to solve for A. So I've got A as the opposite, and I want to relate that to the side that I do know, which is the 15. So if I say I've got A over 15, that would be the opposite divided by the hypotenuse. So what ratio is opposite and hypotenuse? Well, if I look back at my reference sheet that I made, I would know that that is sine. So I would say the sine of 28 is equal to A over 15. Now, what we can do is we can go over to our graphing calculator, or our scientific calculator. I'm using Desmos right here. So if you go to desmos.com/scientific, you can get this calculator. So I can just type in what is the sine of 28, and I get this value. Now, before I go any further, I do want to point out that this is 28 degrees. So I want to make sure that my calculator is in degree mode. All scientific calculators can switch between degrees and radians. We'll talk about what radians are later on, but for today you want to make sure that your calculator is in degree mode. You can test that out. Type in sine 28, you should get 0.69471568. Your answer should match. If I'm ever not sure, I just remember that the sine of 90 degrees is 1, and I go and I type in sine of 90 and I see that it is 1. If I end up getting 0.89399666636, then I know that I'm in radians. Sine of 90 is 1, sine of 0 is 0. Those are just quick references. Anyway, sine of 28 is 0.469, we'll round to 5. 0.4695 equals A over 15. And now this is turned into an Algebra 1 problem where I could just multiply both sides by 15. And we'll go back over to my calculator over here. We'll just go times 15. And I get an answer of A equals 7.042. Now, I still need to solve for the third side, the hypotenuse. So now that I have two sides, I have a choice. I could use trigonometry again, or I could use the Pythagorean theorem. I'm going to choose to use trigonometry again, just because that's the new skill that we're learning. So that means that now I will be talking about, make this big again, side C, and I'm going to compare that to 15. So now I have the hypotenuse over the adjacent. So again, looking back at my cheat sheet, I should see hypotenuse over adjacent, that's the secant of 28. So going back to the calculator, so in order to calculate this, we're going to go back to our calculator. And here's the weird thing. Right here I've got sine, cosine, and tangent. But the one that I'm looking for is the secant. So if I push secant 28, I get this little warning and it says this calculator does not support the secant function. Some calculators have a secant button, some don't. So here's what you do if you don't have secant. Secant is the opposite function of cosine. So I can do cosine here. So what I'm going to do here is just do 1 over cosine 28. 1 over cosine 28. And that's 1.1325. So I get 1.132, and we'll round that to 6 equals c over 15. And then we'll just take that and we'll multiply it by 15 on both sides to get 16.989 is equal to c. And now we've got the final value for our triangle. Our triangle is solved.